Functional programming is a way to write software using functions. It focuses on writing pure functions, avoiding changing data, and using functions that take other functions as inputs or outputs. Let's break down the main ideas of functional programming. A pure function always gives the same output for the same input and doesn't change anything outside itself. Changing anything outside the function is called a side effect. Immutability means you don't change data once it's created. Instead, you make a new data with changes. High-order functions take other functions as inputs or return them as outputs. So now let's look at some examples. Like we have determined before, higher-order functions are functions that can take other functions as arguments or return them as results. Like you can see, the apply function takes a function and a value, applies the function to the value, and returns the result. Square is a function that returns the square of a given number, and when used with apply function, it squares the provided number. So what does immutability mean? Immutability means that once a data structure, like an array or object, is created, it cannot be changed. Instead of modifying the existing structure, you create a new one with the desired changes. This approach helps to prevent unexpected side effects and makes the code more predictable and easier to debug. The function addNumber to array demonstrates immutability by returning a new array with the added number, leaving the original array unchanged. This approach ensures that the original data structure remains intact, adhering to the principles of immutability. Immutability can lead to higher memory usage because any modifications to a data structure results in creation of a new version rather than alerting the existing one. Persistent data structures, which are often used in functional programming, try to optimize memory by sharing parts of the structure, but still require extra space for new elements and metadata. Consequently, while immutability offers benefits like predictability and easier debugging, it can increase memory consumption due to these additional structures and management overhead. Immutable JS and Image.js improve memory efficiency by using structure sharing to reuse unchanged parts of the data structure, reducing overhead from duplicating data. It also ensures predictable behavior and easier debugging by preventing data mutation while efficiently managing updates to large datasets. This is a simple example of just adding two numbers together. This function is pure because it produces no side effects and every operation contributes to the end result. So for a rule of thumb, one could say as long as the operations contribute to the end result, the function is pure. In this case, we have the function addLogger, which adds two numbers together and logs it to the console. If you have been careful listening, you probably noticed that this function is not a pure function due to the console log. This is a side effect and does not contribute anything to the end result. So now you probably see in some scenarios it's hard to almost impossible to write only pure functions. Like you can see, this function fetches a user from the API endpoint and contributes to the end result. Even though we defined earlier that the rule of thumb is as long as the operations contribute to the end result, the function is pure, is not true in this case. A fetch request in a function is not considered pure. Let's break down why this is the case by revisiting the definition of a pure function. A pure function has to be deterministic, so for the same input, a pure function always returns the same output, and there is no side effects allowed. A fetch request is non-deterministic, because it can produce different results even when the given input is the same, due to the factors like network latency, server state, or the server being down. Fetch requests involve side effects by performing I/O operations. They interact with external systems like web servers, which can lead to change in external state. And also there can be logging state changes on the server. Therefore, fetch requests produce side effects. So why should you care about functional programming? Pure functions and immutability lead to more reliable and bug-free code. Without side effects, tracking down issues becomes simpler. High-order functions promote code reuse and cleaner modular design. And immutability and pure functions make concurrent programming safer and easier to manage. But don't be discouraged if not all your functions are 100% pure. For a program to have effect on the outside world, it has to produce side effects.